What's up? We back with another edition of the Magic Flat Earth, the Equator Part 3. First, I want to mention what I spoke about in Part 1 and 2. I dealt with the equator and how the star trails appear to move in a straight arc over top of the equator, which doesn't make sense on a stationary flat earth. And if it is rotating around, or the stars trails are moving around Polaris being the center point, then why would it make straight lines at the equator? It just doesn't make sense. And if we're standing on the equator, how we can see where, if we look south or north, we can see that the star trails are beginning to arc in opposite directions, which absolutely makes no sense. Absolutely makes no sense on this. It just doesn't. And then part 2, I spoke on how what we call in the northern hemisphere hurricanes and typhoons rotate in counterclockwise direction, and then in the southern hemisphere how they rotate in clockwise direction due to the Coriolis force, which absolutely makes no sense on a stationary flat earth. And that they are not, these hurricanes or cyclones are not created within 5 degrees of the equator. And they do not cross the equator as well. On a stationary flat earth, why would that be happening? They can't answer. I've yet to get an answer. And all I've gotten is nonsense deflection. And as many people say, nuh-uh. Anyway, today on part 3, the Magic Flat Earth, the Equator Part 3. Okay, let's start. During the equinox, the sun appears to traverse directly over the equator. So one of the consequences of that is that if you're on the equator, if you're in the city on the equator, the sun rises due east and it sets due west, or 90 degrees east and 270 degrees west. Also on that same day, 99% of the earth can see close to the same thing. So that means that 99% of the earth, or somewhere close to that, can actually see the sun setting due east, or nearly due east, or nearly 90 degrees due east, and setting nearly 90 degrees due west, regardless of where they're at on the earth. So, and the globe easily explains this, because on the equinoxes, the earth meaning, is in a position in its revolutions around the sun where the tilt of the earth has no bearing on the daylight coming from the sun. So, in other words, the earth is not tilted away or towards, in any hemisphere, towards the sun. It's not going away from the sun, it's not going towards the sun. But it's at an angle to the sun where the tilt of the earth becomes almost null and void, right? So, like, if we go to a city near the equator, or that's on the equator, like Quito, Ecuador, we can see that during the 23rd of September of this year, which that is the day of the equinox, we can see that the sun rises 90 degrees east, due east, and it sets 270 degrees due west. And this what is expected if you're at the equator. However, because we're on the equinox, you not only have that happening, you also have 99% of the earth gets a little over 12 hours of direct sunlight. And that's because a little over half of the earth is receiving direct sunlight at any one time, which this illustration easily explains why you would see that, right? It easily explains it. Let's go to a couple of cities on different latitudes. If we start at Danburg, Greenland, which is within the Arctic Circle, so it's far north from my location in Washington, D.C. But on the 23rd of September, we see that it's September 2023, and on the 23rd, the sun rises 87 degrees due east and sets 272 degrees due west, or not due west, but close to it, and close to due east when it rises, and it has a little over 12 hours of daylight, or 12 hours 21 minutes of daylight during that day. This is the equinox, the 23rd of September. Okay, so that's what we expect to see there. If we go a little further south where I'm at, in Washington, D.C., during the equinox, September, if we go to the 23rd, the sun would rise 89 degrees east and set 270 degrees west. And we have 12 hours, 7 minutes of direct sunlight. Think over that now. We are a lot further south than Greenland. But let's go even further south. Let's go to Rio de Janeiro. And we go to the 23rd of September, and we have the sun rising 90 degrees east and setting 69 degrees west. And it has 12 hours, 7 minutes of direct sunlight on the equinox. And let's do one more city for good measure. Go further south, one of my favorite cities to talk flat earth about, and that's Ushuaia, Argentina. And if we go to the 23rd of September, we can see that it sets or rises 91 degrees east, and it sets 260, is that 8 degrees west, and it has 12 hours 13 minutes of daylight. I just want flat earthers to think over what I'm saying. How can you explain that on especially an AE style flat earth map? And really, it's no other flat earth map that can explain this, that makes any sense anyway, that can explain what we see. If I'm down in Ushuaia, I'm getting not only 12 hours of daylight, but I'm seeing the sun rise and set virtually due east to west. If I'm in Rio de Janeiro, I'm seeing virtually the same thing, having the same amount of daylight, and it rising and setting for me in both directions, appearing almost due east and setting. Oh shoot! I think in Rio de Janeiro it was due east and setting virtually due west. And for the other locations, DC, as well as in Greenland, it just doesn't make sense, folks. This is something that we can observe, we can empirically observe, and it doesn't make any logical sense on the flat earth. But it's easy to explain on the globe earth. It ain't hard. So how does this work on the flat earthers? You know, I got an answer for you, because you ain't gonna answer it. It doesn't. Oh, yeah. Ho. One more thing. I noticed this when I was going through the process of looking at the daylight or direct sunlight that each place is getting. If you notice at the equator or Quito, it had 12 hours, 6 minutes of direct sunlight. The further we moved north or the further we moved south, the daylight or direct sunlight got longer and longer. So the further you were from the equator, the longer your direct sunlight was for that day. Whether you're south of the equator or north of the equator. Please tell me how that makes sense on the flat earth. You already know the answer.